Welcome back to another Thursday of learning. And again, today we have 4 Geek Talks. This is option 1 for SQL Maestros, where I'm going to talk about SQL Server internals for developers and DBAs. Followed by that, during the day, we have Geek Talk on data science algorithm. And then again, later in the evening, we have Geek Talk on query tuning. And then I'll be back again with option 2 of SQL Server internals for developers and DBAs. My name is Amit Bansal, and I'm going to be your host and speaker for this Geek Talk. So let's get started. There's a quick introduction about me in the chat window. I have been working with SQL Maestros for a couple of years now, and on the community front, we do a lot of community stuff with Data Platform Geeks, SQL Server Geeks, and of course, the flagship conference that is coming up in November end, which is Data Platform Virtual Summit. That's the background that I have. If you have time, visit dataplatformvirtualsummit.com. More than 200 breakout sessions are going to be delivered as part of this conference by Microsoft experts and global MVPs. And all the sessions are going to be recorded and will be made available to the delegates. And there are more than 30 training classes also. And for the first time ever in the conference circuit, we are recording the training classes as well. So everything that you attend live, you will be getting recordings of that. And that's a great thing. And of course, the community is the conference is very, very affordable in terms of pricing. So do not miss this opportunity. Visit dataplatformvirtualsummit.com. With this, let's get started with today's topic and demos. Let me switch to, so the first thing that I'm going to do is pick up this particular slide and let me share the screen. And you can just wave in the chat window if you're able to see the screen. Yes, so can you see that in the chat window? If you can see the SQL Server architecture in front of you. All right, so we are going to talk about SQL Server internals for developers and DBAs, and this is a very common slide. You will see this kind of diagram about SQL Server architecture in the older MSDN documentation, and today as we call that as MS Docs. So first thing what you will see here is that the SQL Server engine, the SQL Server exe that you are running is divided into 4 subcomponents, so to say. So we have protocols as the first component, the relational engine, storage engine, and SQL OS. Now, this is a graphical representation. It does not really mean that these components are stacked up the way the diagram shows up. So it's not that protocols are above query processor or the storage engine is below relational engine. It does not mean that. This is just a diagrammatic representation. Now, when you submit a request to SQL Server, let's say a simple select statement for execution, your query, your select statement has to pass through these major components and all the subcomponents within them, which means protocols is the first component that will talk to your client because you're going to establish a connection with the SQL Server engine. And I'm sure you know about the protocols like TCP/IP, shared memory, named pipes, etc. So these are protocols that will help establish a connection with the client. The moment the connection is established, the query gets submitted, and there comes the next component, which is query processor, which is also called as relational engine. And if you look at the diagram carefully, the query processor just below the protocols is divided into multiple subcomponents. Again, you have the parser, the optimizer, SQL manager, database manager, and query executor. Now again, these are just some names that I have picked up and I have put them there. But remember, end of the day, all these components and subcomponents are nothing but DLL files that are part of SQL Server installation, SQL Server engine. So what really happens in the relational engine? Well, the first thing is your query is checked for syntactical correctness. The select statement that you have written, does it really make sense? That is done by the parser. And if it is not correct, if the syntax is not correct, the error is thrown back to the client. And if it is syntactically correct, a query tree or a parse tree is prepared. That parse tree is an internal form that is sent to the optimizer. And optimizer, many of you might have heard about optimizer, in your experiences with SQL Server on and off. Optimizer is really the black box, one of the most sophisticated pieces of code inside the SQL Server engine, and is responsible to produce an execution plan. Optimizer decides how your query is going to be executed, and it takes many things into factor. Um, so now talking about optimizer is of course beyond the scope of this session, but quick things, right? Of course, it's going to take the current resources that are available, the indexes, the statistics. Many of those things are taken into account, and the optimizer prepares a execution plan. Well, the job of the optimizer here is to ensure that it produces a good execution plan so that your query runs fast enough. That's pretty much the idea behind. And theoretically, it can compute hundreds and thousands of plans, but of course, it's only going to output one plan. So a lot of optimization phases, a lot of considerations, permutations, and combinations happen inside this black box. Once you get the execution plan, then comes these components like manager, database manager, SQL manager, and finally the query executor. The plan that is created has to be stored in the plan cache, and then one copy of the plan has to be passed on to the query executor, which will execute it. The moment execution comes into the picture, you need data, and that is where storage engine comes into play, because the execution plan is going to decide how are you going to fetch the data. Are you going to scan? Are you going to seek? Are you going to do bookmark lookups? So on and so forth. And that is where storage engine will come into play. And when you look into storage engine component, there are so many subcomponents in the storage engine, which is like file manager, the buffer manager, the lock manager. Now think about it: when your query runs, all these subcomponents talk to each other and ensure that asset properties are maintained. For example, atomicity, consistency, isolation, durability, right? That comes in the transaction umbrella, and all sorts of locks that you have been asking for, whether it is an update query, whether it is a select query. The buffer manager comes into play because someone has to really check the data that you are requesting, which is stored in SQL Server 8K pages. Are those pages already in memory or not? If they're not, then someone has to fetch them from the disk. So you see a lot of these subcomponents will come into play. They're all part of the storage engine, ensuring that the data is served to the client. And while all this is happening, you need resources, right? You need CPU, you need memory, you need IO ports. And these three, that as we call this as the Holy Trinity, we need these resources which are part of the SQL OS. SQL OS stands for SQL operating system. And the whole idea is the basic functionalities of an operating system are part of SQL OS, and that will help execute your thread, the thread management, the worker management, the task management, the scheduler management, which is like your logical processors. All this is done by SQL OS. So if you see in totality, these four components will talk to each other and all the subcomponents and take the request, process it, serve the data to the client. I've given a very simplified overview, but what is interesting for all of you will be the next slide. So query lifecycle. So now I will just show you a diagrammatic representation of how the query flows. So here are some of those subcomponents. Now I'm showing you the execution part of it. What I showed you earlier was just a very high level overview of what SQL Server architecture looks like. And what is the query lifecycle here? So first thing is tabular data stream, right? TDS is the internal protocol. And your SQL statements and all of that is encapsulated into TDS packets, and which is nothing but a representation of TCP/IP packets, and are sent to the protocol layer, right, which is the SQL network interface that is called as SNI. And then that is sent to the relational engine. So now you see I've given a different representation of the relational engine. The request goes to the command parser. So you have the optimizer, the query executor that is part of the relational engine. So the protocols, TDS packets are being received, and of course they are uncompressed, and the internal language that SQL understands, the internal form, it's converted to that, and it goes to the command parser. The parse tree gets created, or the query tree, either way, and it goes to the optimizer. The optimizer will prepare an execution plan, and you can see the query plan, and the query executor is the component that is going to execute the query. But remember, one copy of the plan also goes to the plan cache. So at the bottom, if you see, you have the buffer pool, and in the buffer pool you will see buffer pool has different components, but two memory areas of the buffer pools are the plan cache and the data cache. And one copy of the plan goes to the plan cache. The data cache is the portion of the buffer pool which has the data page and all the data pages that you are going to read. So the copy gets stored in the plan cache, and now the query executed at the same time is executing the query, which is where access methods get called. Access methods are defined by the plan itself, where, as I said earlier, are we going to scan, are we going to seek, how are we going to fetch the data. So that is where access methods will come into play. And then look at this, access methods are constantly talking to the buffer manager. So buffer manager is the component in the storage engine which is responsible to fetch the data from the disk into memory. So the two things that it can do, the data that is being requested by the execution engine, by the query itself, the buffer manager will first check if those data pages already exist in the buffer pool. Remember, there is a data cache, and SQL Server would love that all the data pages are there in the memory. So that is going to be checked first, and if it is not available, it's going to suppose it's going to be available, then it's going to fetch from the memory and it will serve the client. But if the data page is not available in the memory, then it's going to fetch it from the storage, which is the data file, and they are residing on the disk. So fetch them from the data files from the disk and put them into memory and send the request back to the client. So this is really what happens inside. And one last thing what I want to show you, and I will skip some of these, are part of our video courses and whatnot, but I'm not covering this stuff. But I want to cover the too much of stuff there. I mean, this is just a 45 minutes geek talk. I want to show you the execution part of it. Now, another representation of internal. So we talked about the high level overview. We understood the life cycle, and now I'm going to show you step by step. So the user connects with SQL Server. A session gets established, and here comes our favorite DMVs. So sysdm exec session will have information about the session, and then user is going to send a select request, right? A select statement is being sent, and that comes to SQL Server as a request. So you can see that in the DMV dim exec request. So now you can see there are two DMVs that I'm showing you right now. Now the request has come to SQL Server. It's just a request. It has to be converted to a task before it starts executing. So what SQL Server will do will convert the request into a task. And now you can track all the tasks in a DMV called DimOS tasks. Now remember, for a single request, you can have a single task that is serial execution, but sometimes you can have parallel execution if the query is complicated or more complex and the optimizer decides that I want multiple threads to execute this query. Then in such scenarios, for a single request, you will have multiple tasks. And then what happens is task is now part of the OS component, and it has to be executed. So for that you need a thread, and then thread is going to be pulled up by a worker. Now remember, thread is the lowest unit of execution in computer science, and I'm sure you must have read a lot about that. But there is another thing that comes into picture, which are called as workers. Now workers are logical, but threads are physical. Threads actually consume resources. They consume memory, they consume CPU cycles. But someone has to do the job of taking a thread from the operating system and scheduling it on the scheduler. That job is done by the worker, the logical component. So you can track all the workers in DimOS workers, and then the moment it gets the thread, those threads that are executing the task, you can track them in sysdimOS threads, and then the threads are scheduled on the schedulers. On the bottom right corner, you can see the schedulers. You can see that there are 4 logical processors, and your thread is running on that. Again, a very simplified overview, but is quite complicated if you go and dive deep into all this stuff. Schedulers are nothing but logical processors. Like, that's a different discussion altogether about cores, physical cores, logical CPUs, physical CPUs. But anyway, in simplified statement, they are logical processors. What you will also observe that, when we talk about these DMVs are quite crucial when for developers in DBAs, if you're even troubleshooting performance stuff, or even for developers when they're knowing and learning a little more about SQL Server, DMVs come very handy. On this slide, I am showing you 5 DMVs, if you see, but uh, look at how the naming convention is. The first set of DMV says dim exec sessions, exec session and request. So they are under the category of execution. So exec stands for the execution model there. And the other 3 DMVs come under SQL OS. And you can see the prefix dim OS tasks, OS workers, and OS threads. So they come under the SQL OS engine. I mean, that's another evidence that, of course, these are different components. And of course, the request goes back to the client. That's pretty much it in terms of a very basic overview of what SQL Server architecture really looks like, various components talking to each other, the query lifecycle, the thread and workers, coming in tandem and working together to serve the request. Now it's time to jump into demos, and let's do that. And I'm going to share the screen. So before I jump into demos, if you have any questions, why don't you put them in the Q&A panel, because we talked about the theory behind SQL Server internals, and that was a very, very quick overview. If you are watching live on YouTube channel, you can join in into Zoom and you can use the Q&A panel. But if you're comfortable on YouTube, you can put the questions in the chat window, or just go to sqlmaestros.com/live. That's the place from where you would have registered for the event. So while I pull up the demos, let your questions keep coming in the Q&A panel. Okay, so I hope all of you can see your favorite SQL Server Management Studio out there. Okay, perfect. So let's get started. So first, what I am going to do, because I talked about this plan cache, and I talked about the buffer pool. I want to show you those components, right? So what I will do right now here is pull up a query here, which is buffer pool usage. And what I am going to do is I'm going to run only one query right now here, which is, let's say, how many pages in the buffer pool do I have for AdventureWorks 2016? This is what I'm going to do. Now, see this. And I'm going to show you the entire thing that I talked about. I'm going to show you the complete flow, what you saw on the PPT. But before that, there is a DMV called DemOS buffer descriptors that will tell you exactly what is there inside the buffer pool, inside the memory area. If I run this right now, you will see that for AdventureWorks 2016, there are about 165,000 pages. Those are the clean pages, and you have about 51 dirty pages. Note these numbers. What I will do now is I'll fire dbcc drop clean buffers. Okay, and I am going to execute this. I'm going to clear off the buffer. Now, never do this. Okay, what's the statement? Drop, drop, early morning spelling mistakes. Okay, dbcc drop clean buffers. When I execute this, you can see the statement has executed successfully. Now I have cleared off everything from the memory. Warning, don't ever execute this statement in production environment. This is just a demo. So I'm trying to just show you a few things. So I've used that statement. Be very careful. Now, if I execute this, you can see that there are no clean pages. So clean pages have completely gone because I cleared off the memory, right? Keep this in mind. Now, which means there's nothing in the buffer pool. Now there is something called as the plan cache. So let's fire a new query and write a statement called select star from sys.dm underscore exec underscore cache plans. Yeah, that's the one. And instead of, okay, so let me just show you first that there are a lot of plans in the plan cache right now, about more than 100 plans. You can see all the plans that are there. If we do a quick count of these, you can see 128 there, and I'm going to do the same thing. Remember, plan cache was also part of that diagram about that flow. Once a query plan is created, it gets stored in the plan cache. So I am going to say dbcc free proc cache, and I'm going to clear off the plan cache as well. Again, another warning, don't use this in production environment. This is just playing around and learning SQL Server. Now, if I execute this, you can see that there are just two plans in the plan cache. So what I've done is I've cleared off the memory and I've cleared off both the portions of the memory, the plan cache as well as the buffer pool. Now what we're going to do, we'll keep this alive and we'll keep this also alive here. And let me close all of this, too many windows. And now we will take up the query, which is thread lifecycle. That's what we are going to do. And this is the select query here. So I'm going to create a scenario now, right? I'm going to create a scenario where one query will fire an update statement, another query is going to fire a select statement. The update statement will block the select statement, and then we will go and look into various things. So let's open up the update statement here. This is the update statement in AdventureWorks 2016. A very simple update statement, and we're trying to say begin the transaction, update a specific table with some record. First name is equal to Ken. Ken is instead of Ken, let's make it Amit, will become more exciting. And then I'm not going to roll back the transaction, right? So this is going to be an in-flight transaction. Now I also want the SPID of this one because I'm going to use it in the DMVs to capture the internal information. So let's go and execute this. When you fire this update statement, it does it, and you can see that session ID 86 is the update statement, and you can see one row affected. Okay, keep 86 in mind. Now let's go and fire the select query. Where is our select query? This is our select query. Again, I need the SPID, AdventureWorks 2016. We're going to fetch data from the table, and this is 51. Now look at the status bar. Observe that select statement has not completed because it's being blocked by the update query. So 86 is the blocking query, and 51 SPID 51 is the blocked query. Now let's go and look into threads, workers, tasks, sessions, requests, so on and so forth. So 86 and 51. Here is our query. Where is this? There you go. No, not this one. Okay, so let me just pull this down. Thread lifecycle. Okay. So what I'm going to do here is I have written a couple of stuff there. If you can see, don't worry about all of this. We can share this with you. But what I'm trying to do, this is my update query, which was 86. And this is my select query, which was 51. Okay, and now we are trying to fetch the data from exec sessions. So let's go and execute this. What you're going to see, of course, you will see two records. Now there are a lot of attributes that I can show you, and it's overwhelming. Each DMV has like dozens and dozens of attributes, and they have a lot of meaning behind them. But for this very simplified Geek Talk session, what I want to show you is sessions 86 is right now sleeping and 51 is running. Now let's try to understand from the session perspective. This is from the session perspective, not request, not task. You have to understand these are different layers and they have different meaning. 86 is the session that has the update query. It has done its update and now it is kind of sleeping. It's not doing anything, but the transaction is still active. Okay. Session 51 is constantly running. Why? Because it's being blocked. It's constantly trying to fetch the data. It's constantly trying to acquire the shared log. That's why session 51 says running. Now let's go and look into the request. Now we're coming down one level down, so to say. So we change this back again to 86 and this one to 51. So let's go and execute the monitoring. Look at the request status. Now, what does the request say? First surprising thing about session ID 86 does not have any active request. And now you can comprehend that because session ID 86 has fired its update statement and that update statement was complete. Agreed that the transaction is still alive, but there is no active request. However, for session ID 51, there is an active request, which is that waiting request to execute that select statement. It's still waiting. However, status is suspended. Status is suspended because it's waiting for a resource. When a workload is waiting for a resource and is waiting on a specific wait type, the request status goes as suspended. The moment that resource will get active, resource will be available, the status will change again to running. Now, this was in the execution layer. Now let's go to the SQL OS layer. And in the SQL OS layer, I'm going to show you the task. So as expected, I'm going to play around with dim OS task. Remember this, I showed this to you on the slide. Now let's go and check the task status. So, okay, sorry, I need to change the session ID 86 and 51. Let's go and execute this. And you are going to see that again for session ID 86, there's no active task. If there's no active request, there will not be any active task. And for session ID 51, there is one task which is again suspended. Very similar. Let's look at the workers now. So you have dim OS workers DMV that I'm playing with now. And again, let's play around with this 86 and 51, and let's go and execute this. Okay, no active workers at this point for us to see, simply because workers have done their job. Threads are already active. And let's go and join. No, so we need to monitor workers. Sorry, the workers should be active. That's what I was. Okay, let's try this one now. Let me see. Okay, so you can see no active task, so there's no active worker. But for the second 156, there is an active worker which is currently suspended. And this is where you can see all the suspended and runnable durations, etc. This is a bit of monitoring query, but good enough for us to, I mean, this session is not about troubleshooting performance stuff and all of that, but still just to play around with this, you can currently see what's going on, right? Session ID 81 says running, 51 is suspended, etc. So that's where we have. Now let's go and yeah, remember one thing, in this there was no session ID 86, right? Because 86 is not currently active, there's no request. Now let's do one thing. Let's go and roll back the transaction. What will happen when you roll back the transaction? This select statement will go through, which is currently waiting. So let's roll this back. And now if you come here, you will see all the data has come. Now all the data has come, which means this select statement will be in the plan cache, right? Point one. Point two will be all these pages, you know, these records are now in the memory. So in Adventure Works, you will see some in the buffer pool, you will see some pages for the AdventureWorks database. So remember, this was the query we ran. We had only dirty pages. We had no clean pages. Now I'm going to execute this again because this data was fetched from disk into memory. So let's go and execute this. And now you can see that about 4,000 pages have been brought into memory. So you can see clean pages and dirty. So if you're wondering what is the difference between clean and dirty pages, when you have clean pages in the memory, which means they are like fetched from the disk, but no changes have been made to them. And if changes are made to those pages, let's say, you know, you fired an update statement that have modified a few pages, then internally the terminology is they're considered as dirty pages and they have to be written back to the disk to make them clean again. That's the kind of idea behind clean and dirty. Okay, so you now see data has come into memory. And what about the plan cache? That's the another thing that I was trying to show you. So let me close this window and see where is the plan cache query. And I just was writing something. Here you go. Now look at this. What am I trying to do? This maybe if you're new to SQL Server, this might be a bit overwhelming in the beginning, but that's again a very simple query. What are we trying to do? We are trying to find out all the execution plans. So if you remember, I just wrote select start from sysdm exec class cache plans, but now I want to specifically find out my execution plan. So what I am doing here is I am using this particular DMV, sorry, and I am joining it using cross apply. What is cross apply is not part of this session. So I'm cross applying with sysdm exec query plan, which is another DMF, I should say. This is a dynamic management function. It takes one parameter, which is the plan handle. The plan handle comes from this DMV, right? And then I'm joining in again with another DMF, which is dim exec SQL text, to get the actual text of the query. And it also takes plan handle, which is coming from the cache plan. So cache plan has the plan handle, which gets supplied to the query plan to extract the plan, and which gets supplied to dim exec SQL text to extract the query text. And then I'm filtering that the query text has to be like person dot person to just get my query. So if I do run something like this, it'll give me all the plans, all the execution plans you can see here, and I can just click on them and I can open the plan cache. I can open the plan in in a separate window, and you can see even the query on the left hand side. But I am interested in only figuring out about my query, which has anything text like person dot person. So I can execute this and I can get the output, and you can see that I have the plans coming in, all these plans, and this was the select statement. Select start from person dot person, and if you click on the execution plan, this is the execution plan, the most simplest plan you could probably see: a select operator and a cluster index scan. This is the plan that was created by the optimizer, right? So to summarize what you have seen, the request coming in, dim exec sessions requests, and then it goes to the optimizer. Optimizer prepares this plan, then plan is stored in the plan cache, and I showed you the plan cache, and I retrieved the plan from the plan cache. And when the query gets executed, it fetches the data from disk into memory. First I showed you that the memory was empty, or I emptied it, and then we fetched the data into memory, and then I showed you that it had the clean pages. So overall, just a very quick overview of what SQL Server internals looks like. Now, it is equally important for developers and DBAs to be aware of what really happens with the query inside the engine. DBAs definitely, because you're the one who is managing the databases, you're the custodian. If things go wrong, you're the one who's called upon. So you ought to know, especially when you're doing performance tuning stuff, you're doing query tuning stuff, you got to know these internals. These internals are just not enough. I mean, this is just a very tip of the iceberg, very surface overview. Developers sometimes wonder, why do we need to know about such internals? Well, you need to know because you are writing the query. So you want to know what happens with your query inside the engine, how it gets executed. If you know how your query gets executed, you will be able to write better queries because you know how your queries are going to be treated inside the engine. Of course, in this session, we didn't talk about the developer stuff too much, but there are many developer best practices, T-SQL best practices, how you should join, how you should sort, how you should use expressions, parameters, dynamic SQL. There's so many things. Unless you do not know how those T-SQL constructs are treated inside the engine, you will not be able to write good queries that are performing well in the production environment. And that's why I say internals are equally important for developers, DBAs, architects, data engineers, database engineers, so on and so forth. Well, with this, I come to an end of this, a small bit of theory, bit of demos. Hope you like this Geek Talk. If you are sticking around for questions, please do so. But if you are not sticking around with questions, I mean, if you do not have questions and if you're about to leave, please make sure that, let me just stop sharing this. Make sure that you visit Data Platform Virtual Summit. I also have a class as part of this summit. And apart from so many other classes that we have, and maybe I'll just share this one with you so that just to make you aware. So there are, as I said, there are about 30 training classes that we are doing as part of Data Platform Virtual Summit. I also have a class. Let me tell you, my class is not the best class. The remaining 29 classes are the best classes out there. So go on and see, those are 8-hour deep dive classes on many technologies: SQL Server, Power BI, artificial intelligence, data factory, data science algorithms. I don't know, too many of them. The best part is you can attend live and you get the recordings for those classes for which you have registered for. So that's a great thing. And so which means you can watch those recordings as many times as you want, etc. So log on to dataplatformvirtualsummit.com and explore more. And those were about the classes, the pre-cons and post-cons. We collectively call them as classes. Overall summit will have about 200 breakout sessions spread across 6 parallel tracks: roundtables, open talks, chalk talks, and general sessions. All of them are going to be recorded and will be made available. So that's about dataplatformvirtualsummit.com. I am available on Twitter, _Bansal. I also have an exclusive subscriber list, bit.ly /connect with AB. You can subscribe to that if you want more SQL Server stuff, learning stuff in your inbox. And you can visit sqlmaestros.com to get access to more videos and more learning resources that we have on the website. So all the links are there in the chat window, and now is the time to get started with questions. So let's go to Q&A panel and see what questions you have. Okay. The first question is, same stored procedure. I think by SP you mean same stored procedure on different server with same configuration, take different time and execution plan also same. One server takes 10 seconds and the other one takes 10 minutes. Can you please explain? So the question is, there is a stored procedure which takes 10 seconds on one server and takes 10 minutes on another server. What could be happening inside the engine? Well, parameter sniffing could be happening inside the engine. Something to do with the plan cache could be happening. Lack of resources could be happening. Maybe the statements that are there inside the stored procedures, they could be waiting for something. So what you need to do is you don't really need to bother much on the server where it's running fine, but the server where it's taking 10 minutes, try to troubleshoot and figure out by first thing, of course, by looking at wait stats. Try to capture using extended events. You can capture what is your query, your stored procedure waiting on, because your stored procedure has multiple statements. So when you're running it in production environment, with the help of extended events, capture that information, because the wait types will give you some hint as to when the stored proc is running, what really is it waiting for. That could be the beginning point. And from there you will find out your route. Is it waiting for extra memory grant? Is it waiting for CPU cycles? Is there some locking blocking happening, right? I mean, those kind of things. Okay, the next question is, any way to find out from which session ID was plan created? So Vignesh has a question, is there a way to find out which session ID actually created the plan? No, Vignesh, I do not know if that information is stored inside the internals. I might want to get this information. You may want to try to do something. Try to get the XML version of the plan. Open it up in Notepad and look at the elements and try to see. Search on ID or session ID or session underscore ID. Maybe that will give you. And if that doesn't give you, there's no other way. But if you really have a need to capture that information, maybe you can use extended events. That will help you to capture the session ID and the plan both itself, so you can know which session ID is created. By the way, I'm curious to know, why do you want to find out which session ID created the plan? I mean, how does it help? What is your scenario? All right, are there more questions? If you like the sessions, do give some feedback on social media, and very soon our live page, SQL Maestros live page, will be updated with the next live talk, which is going to be on October 15. And on October 15 live talk, we are Geek Talk, we are talking about T-SQL tips and tricks. So that information will be up in soon. You're already subscribed and registered with us, so you will get email notifications.
There is a question from YouTube, from Javier.
Okay, yes.
Great online meeting. Some book do you recommend for these topics?
Wow, books. Yeah, of course. There are a lot of books, in fact. And one book that immediately comes to my mind is Kalen has a book on SQL Server internals. I don't know if that has been updated with latest versions, but you may try your hand on that SQL Server internals. Just search on SQL Server internals book Kalen. Go to your favorite search engine and do that. You may get a book. Then Itzik has books on T-SQL, where he also covers a lot of internal stuff as part of his T-SQL. So he has books, T-SQL querying, T-SQL programming. Those are good books. Itzik is doing a training class with us at Data Platform Virtual Summit. You may want to attend that. He's doing 2 classes there. And we have more. In fact, I want to let you know there are more classes apart from my performance tuning classes. Uvi Ricken is also doing a SQL Server optimization class. And Eric Darling is doing a SQL Server query tuning 8-hour deep dive class. Both of those classes are better than my classes. So if you have a choice to make, go for their classes. Okay. What else? Satya, do we have any more questions?
Yeah, that's all for now.
Okay, perfect. So that's where we are with this. You have all the links in the chat window, and just copy them in your favorite sticky notes or wherever, or just visit Data Platform Virtual Summit or SQLMasters.com and you will get all the links. With this, thank you very much for joining us today. Hope these 45 minutes were worth your time. Hope you learned something new. Give us feedback on social media. Encourage others to come over and join in our upcoming Geek Talks. There are 3 more Geek Talks today. This session is going to be repeated later in the day after about 10 hours for different time zones. So glad I was able to talk to you. See you soon in another video. Thank you and have a good day. Goodbye.